I had a request for number 10. We are given that AB is equal to BC. The only point of that, alright, we're told that AB is equal to BC. Okay? A couple days ago we learned that if a point is equally distant from the endpoints, then it sits on the perpendicular bisector. So by telling us that AB and BC are equal, they're telling us, look, this is equidistant. That means BD here is the perpendicular bisector. You see that it's perpendicular, but so a crucial bit of information is that if these are equal, then this must be a bisector. In other words, AC is being cut exactly in half. That means if DC is 12, then AD will also be 12. So that was one of the things that we were supposed to find, AD. AD is 12 because that's 12. The other thing we're supposed to find is the measure of angle ABC. Now look, the measure of angle ABC is this red angle that I have drawn. This is angle ABC that goes all the way across like this. This is angle ABC. So we're supposed to find the measure of that whole angle. But if these sides are equal, then what we're looking at is an isosceles triangle. This has symmetry. The left side and the right side are identical. They're the same thing. So let me mark these with marks. So this is an isosceles triangle. You could split it right down the middle, and the left side should be the same as the right side. So you see this 39 degrees, and you see this little arrow sort of pointing at it. Let me emphasize it. This 39 degrees right here, okay, they are showing us this angle. Okay, this angle right here is 39 degrees. But we're supposed to find the whole thing. So what is the relationship between the 39 degrees right here and angle ABC all the way across? Well, I'm hoping that you'll realize that 39 degrees must be half. So if I start with 39 degrees and I double it, 39 degrees times 2 is going to give me 78 degrees. Alright, so that should give me the entire angle. 39 degrees is half of it. If I want the whole thing, I'm just going to double it. So that's why angle ABC should be 78 degrees. Okay, so that is number 10. I also had a request to do number 14. Granted, number 14 is a little bit tricky. You might have to watch this part of the video twice. But let's get started. Let's start by labeling the picture with what we have. Okay? Please remember the way a centroid works. Because I believe, alright, I mean, we're told that this is the centroid, okay? We know that this is the centroid. That means, remember how it works? A centroid is going to divide the median into 3 equal parts. So, for example, if the centroid is here, I could also take the longer piece and divide that, and so these 3 pieces should be equal. Like if this is x, this would be x, and this would also be x. So that's what we're working with. Remember, the centroid is going to divide the median into 3 equal parts. Now let's start to label this. We are given dg, 4x minus 5. Okay? So dg is 4x minus 5. Let's put that in the picture. This is dg right here. Okay, and that piece is 4x minus 5. Now, I always want to see my three equal parts. So again, I'm going to take the longer piece, I'm going to split that in half. Now I'm going to go back and worry about the 5x minus 1 later. I'll use that part to make my equation with. I'm going to focus on this small piece though. If dg is 4x minus 5, what's the value of this little piece right here? Guess what? That is also 4x minus 5. Alright, because the key thing about the centroid, the property of it, the centroid will help me divide the median into three equal parts. So these three parts right here are going to be equal. If dg is 4x minus 5, then this piece is going to be 4x minus 5, and this piece is also going to be 4x minus 5. Okay? So now I'm going to look at the other piece of information that we're given and see if I can make an equation. The other piece of information I'm given is bg, 5x minus 1. I feel like I should go to a different color now. I'm going to do green. Okay, they're giving us that bg, which is this part right here, is 5x minus 1. 5x minus 1. That's from here to here. So the trick is to use the red stuff and the green stuff to make an equation. Can everybody agree that the red part over here and the green part over here should be equal? In other words, let's see, let me go to black for a second. Okay, this part shown here in red is the length from B to G, and of course this part shown here in green is also the length from B to G. So the green part here should equal the red part because they're both B to G. So when I go to write my equation, obviously on the left side I'm going to have 5x minus 1. Let me go back to my colors. On the left side of the equation I can put 5x minus 1 because that's what I have on the left. Now on the right hand side I have two pieces that sort of need to be put together. 4x minus 5 plus another 4x minus 5. We'll just combine like terms to make the right hand side of this equation. If I add 4x and 4x, what am I going to get? Clearly I'm going to have 8x. If I combine negative 5 and negative 5, what am I going to get? That's going to make negative 10. That is the key, setting up this equation. The rest is easy. But drawing the picture with the left side being 5x minus 1 and the right side, remember they gave us this little dg at first, and we had to realize there would be three of them, 4x minus 5, 4x minus 5, 4x minus 5. But then we also had to realize that to match this up, the 5x minus 1 is bg, so we needed both of these 4x minus 5s to match, and we had to combine like terms. Once we have the equation, we should be able to solve this very, very easily. I like to start with my variables first always. So I have 5x on both sides. So how shall I proceed? I could subtract 5x or I could subtract 8x. Which one do you want to do? Obviously you can't really tell me. Some people like to keep things positive. Some people always like the variable on the left. I'm going to go ahead and go for keeping things positive. So I'm going to subtract 5x from both sides like this. That's going to leave me with negative 1 equals 3x minus 10. Alright, because these 5x's cancel each other out, left negative 1. Now I need to get 3x by itself, so I'm going to just add 10 to both sides. So I'm going to go plus 10 plus 10. Okay, and so that's going to give me 10 and a negative 1. That makes 9. So I have 9 equals 3x, because of course these cancel each other out. And the rest is really obvious. I'm going to divide both sides by 3. 3's cancel out. So that's going to give me x equals 3. So that is the value of x. Now we might be done or we might not be done. Depends on the directions, which I don't actually see the directions. Are there directions up here? Alright, I'm just going to assume that we're supposed to find x. Okay, because I don't see anything else. So that would be the answer in that case. X is equal to 3. That would be the answer for number 14. By the way, I was just doing number 14, in case you didn't know. Okay, let's see. I think there's one more problem I need to do. Alright, problem number 20 is really 3 separate problems. The first problem with the 8x and the 9x plus 6 is identical to the problem from the lesson, which was called problem number 15. And so if you want to see how to do that one worked out, take a look at the lesson video and it'll show you how to do that one, because I already did that one in the other video. So I will show you how to do the middle one. I might leave you to do the third one by yourself because it's the same type of thing. So let's look at how we would do the middle one. Alright, let's cover this up for a second so I can write on it. Okay, so looking at the NL and the NP. You know what? I might cover the other one up too, just so we don't get distracted. Okay, focus on this. NL is x plus 4 and NP is 3x plus 3. Let's slide over to the picture and label what we've got. Okay, NL is x plus 4. Okay, so that's this right here. NL is x plus 4. And then NP is 3x plus 3. Okay, let's see, NP. That's going to be this part. I feel like I should change colors. NP is this whole thing. Okay, and we're told that that is 3x plus 3. Am I right? Yes. Okay, so I've got these two things. Okay. This one is not going to be it's not going to be quite so easy to do by splitting up into 3 equal parts. So I didn't want to have to do it, but I'm going to have to break down and talk about the actual formulas. Let's look back at the lesson for a second. Okay, I didn't want to have to do it, but I don't see any way around it for this one. Looking back at the notes, when we introduced the centroid, I gave you these 3 formulas. Okay, the relationships between the big part and the small part and the whole thing. Let me get rid of that because we don't need that. Okay, so we learned that see, basically you're going to want to memorize these formulas. Okay, the big piece is twice as big as the small piece. That's the first formula right there. The big piece is twice as big as the small piece. But that implies two other things. Okay, remember how I kept breaking this up into three pieces like this? Okay, that means that another thing that we could say, if I want to talk about how this big piece and how the small piece compare with the whole thing. So remember, the whole thing is this W shown here in pink. So look, the big piece, can you see that that is 2/3 of the whole thing? Because here's a third and here's a third. Alright, so the big piece is 2/3 of the whole thing. And the small piece is 1/3 of the whole thing. 1/3 and 2/3. So that's where these other two equations come from. So altogether we have three equations. The big piece is twice as big as the small piece. But the big piece is also 2/3 of the whole thing. And the small piece is 1/3 of the whole thing. Now keep those equations in mind. Now I tried to spare you from this because I know this is going to feel complicated to you, but I just don't see any way around it anymore. So look at those formulas that I was just talking about. Okay, look at the two types of things that we're given. We're given this red, NL. Is this the big piece, the small piece, or is it the whole thing? Okay, hopefully you can see that this is the big piece. Now what about this green? Is this the big piece, the small piece, or the whole thing? I'm hoping you can see that this is the whole thing. So we've got the big piece and we've got the whole thing. So look at the formulas that we were just talking about. Which one of these formulas am I about to use? Well, goodness, I think I'm about to use this one. This is the relationship between the big piece and the whole thing. The big piece is 2/3 of the whole. Okay, so this big piece is going to be 2/3 of the whole thing. So that's how we're going to write our equation. So watch this. I'm going to start by just writing down the formula in words. Okay, the big piece is going to equal 2/3 of the whole thing. Okay, so now my expression for the big piece is x plus 4. So I'm going to have x plus 4 because that's the big piece. And that's going to equal 2/3 of the whole thing. The whole thing is 3x plus 3. So that's going to be 3x plus 3. Okay? Now what we need to do is just solve this equation for x, and then that'll be how we do it. Alright, but that's another thing. How do I solve this equation for x? I could start trying to do the distributive property, but I think for most of you it would be easier to do the following. Most of us are uncomfortable with the fractions. Focus on the denominator. You see that 3? So the first thing I'm going to do is I could multiply both sides of the equation by 3. So it's like I'm going to put a 3 over here and I'm going to put a 3 over here. I'm multiplying both sides by 3. If I do that, on the right side of the equation, these 3's are going to cancel each other out. Now I can go ahead and do the distributive property. So if I do the distributive property here, that's going to give me 3x plus 12. Now these 3's are gone, I can go ahead and do the distributive property here. That's going to give me 6x plus 6. I can go ahead and solve this now. Let's just subtract 3x from both sides. I see those x's everywhere, so minus 3x minus 3x. That's going to give me 12 equals 3x plus 6. Let's go ahead and subtract 6 from both sides. Minus 6 minus 6. So that is going to give me 6 equals 3x. Then it's time to divide both sides by 3. Divide by 3, divide by 3. So that's going to leave me with x equals 2. Okay? So for that problem, I'm going to have x equals 2.